welcome to part 2. We'll be discussing more miracles in the engineering and intelligent design in something what we seem to look at as something primitive. As you know, that our cells are very complex, it's very living, it's got intelligent design signs in it. But you know, atheists tell us that, you know, these materials here are not intelligent, like plant life and things like this, and this is more primitive stuff compared to the human beings and so forth. But we're going to show you how complex this is, and it points to God. If you haven't seen part 1 of the video, please watch part 1 of the video where we show the growing cucumber and the tendrils, how without a conscious mind and being blind, it still knows how to climb structure, as you can see here. So we've discussed that in part 1, and we've gone through the miracles of intelligent design there. And you know, this isn't just based on chance, this is clearly designed and programmed by God to do those sorts of activities. Now we're going to move right along to an orange plant, and as you can see, here it is. This is an orange plant, and we're going to discuss the intelligent design in the leaves and how amazing and miraculous this is. And it's not just based on chance, but there was a thought process that happened in this plant. So let's discuss some of those issues.
Yeah, we were talking about the waxy cuticle that is on the top of the leaf. That you see how that's waxy, and the bottom part of the leaf is matte. So the purpose of this waxy cuticle is it acts like clothes, like your clothes protect you from sun damage, water damage, this, that, your skin.
Yep.
This waxy cuticle is protective of the plant in a way that it does not let the leaf's integrity be disoriented by the water damage. Just like you do spray paint on the cars and on the things to protect them from rust and water damage. Similarly, nature has done this spray paint sort of a thing that is waxy.
Is that why it's shiny up on top, but it's not so shiny on the bottom of the leaf?
Yeah, because the sunlight and all the harsh environmental factors are faced by the outside of the leaf, not from the inside.
Oh, okay.
The water, when the raindrops fall, they stay on the leaf for some time.
That's like me when I want to put sunscreen on. I don't put it inside my mouth. I put it outside my face because that's where the sun is going to shine.
Yeah, and you don't smudge it too much. You just let it stay as a layer on top. So it's like that layer.
Okay, so it seems to me that an intelligent designer thought about that process. It's not something that is just based on random mutation or selection or natural selection. There's a conscious mind, a super intelligent mind that actually designed this particular thing. And this is just even as something as simple as a leaf. You know, we look at it and say, oh, you know, it's just something very simple. It's just a leaf. But it required a lot of intelligence in designing to withstand some of those harsh conditions.
Environmental factors,
okay,
yes.
Yep.
It doesn't just stop there. It also protects the waxy cuticle. It protects it from water damage, like I was saying. For example, you put Vaseline on your lips, cracked areas of your skin in winter. So, you know, it keeps it moist. It retains the moisture in. It doesn't let the water evaporate.
Okay.
Similarly, the nature has put this waxy cuticle on top, so it doesn't let the water evaporate out of the leaf when the sun falls on it. Okay. So it absorbs the sunlight, but it does not let the water evaporate. But it doesn't just stop there as well.
Well,
because
that's amazing.
You would think it's sealed. So how is the plant breathing?
Right.
So it's not like sealed, like, you know, you put the in airtight container. It's not that sort of seal. The top layer works in conjunction with the bottom layer.
With the bottom layer.
So the bottom layer has little pores. So at night time, these pores, they take in oxygen.
Okay.
Right.
So they've got a different role. The top layer and the bottom layer's got a different role.
Totally different role, yeah. So at night time when they take the oxygen in, and in the morning time when the sunlight falls on the top layer and the photosynthesis is happening inside, this layer on the top, which is waxy, it protects that water and those photosynthetic cells from the heat damage, water damage, and all the. And there's one more surprising part. This top layer, it's not just, yes, you say it's waxy, but it's not the dark green color. The dark green color is the color of the leaf that you see. The top layer, it does not have a color. It's translucent.
Okay.
Why is it translucent now? It's translucent so all the sunlight is received by the plant, because plants basically thrive on sunlight. So it's nature has kept it translucent, so the sunlight comes in, yet it protects it.
Is that why it's darker on top of the leaf?
No, that's what I'm saying. The dark color is the actual color of the leaf. The dark color has nothing to do with the layer. The dark color is the color of the leaf. It's not the color of the cuticle. The cuticle is basically translucent. It's transparent. Like you don't see that, because so that the water can be absorbed, the sunlight can be absorbed by it, but the water doesn't get evaporated because of it being waxy.
Okay.
Yeah, and like you were saying, why is it dark from top and lighter? You turn the leaf and you'll see it's lighter.
So it's lighter on the bottom and it's darker on top.
Yeah, so the darker color, just like we say, you know, when we buy the cars, they say don't buy dark color cars if you're living in the hot climates, because it absorbs a lot of sunlight. It traps the heat.
Okay.
So similarly, this is basically trapping the heat in, and this is dark color here outside, because we are living in this climate where it's not summers all season long, and it's very cloudy mostly. You know, in desert plants,
right,
like succulents, have you noticed they are not that dark green?
Okay.
They are a bit bluish gray shades.
Okay.
You know why they are bluish gray shades?
Why is that?
And they are not dark in color, because the bluish gray shades, they avoid water loss. You know, they avoid the excessive heat into the plant.
Okay.
So they are white, but at this normal temperature where the sunlight is not too excessive, they are dark, so that it traps the light in, and it absorbs. And the bottom doesn't need it, because the sunlight is not going there.
Okay. So even that thought process has been really thought about by intelligent design.